Welcome to Web Lizard Lab's CERT Lab. This is AZ-104 Practice Exam 6, Core Azure Networking. You will work through 31 source-backed administration decisions across virtual networks, subnets, peering, routing, network security, troubleshooting, and Azure Bastion. How this practice exam works. You will hear the complete scenario, question, and every answer choice or matching target. After lock in your answer, you will have 3 full seconds of silence while the complete question remains visible. Then the supported answer resolves in place, followed by the reason it fits and a networking decision pattern you can reuse. Pause whenever you need more thinking time. If you enjoy our videos, please like and subscribe to support the channel. Question 1 of 31. An organization is adding a spoke virtual network that will later be peered with its hub. The hub uses 10.20.0.0/16, and existing spokes use 10.21.0.0/16 and 10.22.0.0/16. The enterprise network team has reserved 10.24.0.0/14 for another environment. The new spoke must contain one future /24 subnet and one separate future /25 subnet. Existing networks cannot be renumbered. Which address space should be assigned to the new spoke virtual network? Answer A, 10.22.128.0/23. Answer B, 10.23.0.0/24. Answer C, 10.24.0.0/22. Answer D, 10.23.0.0/23. Lock in your answer. Answer D is correct. 10.23.0.0/23. 10.23.0.0/23 does not overlap the connected hub or spoke ranges and does not use the enterprise reserved range. It also leaves room for the explicitly required non-overlapping /24 and /25 subnet prefixes. Evaluate a candidate virtual network prefix against connected network overlap, reserved enterprise space, and the complete set of required subnet prefixes. Question 2 of 31. A virtual network has the address space 10.40.0.0/24. Core subnet uses 10.40.0.0/26. AppSubnet uses 10.40.0.64/27, and DataSubnet uses 10.40.0.128/26. The remaining ranges are unallocated. AppSubnet must be expanded from 27 to at least 50 usable addresses. You may redeploy the AppSubnet resources, but Core Subnet, DataSubnet, and the virtual network address space must remain unchanged. Which change should you make to AppSubnet? Answer A. Keep its prefix at 10.40.0.64/27 and add 10.41.0.0/26 to the virtual network. Answer B. Change its prefix to 10.40.0.128/26. Answer C. Change its prefix to 10.40.0.64/26. Answer D. Change its prefix to 10.40.0.0/25. Lock in your answer. The supported answer is C. Change its prefix to 10.40.0.64/26. After the existing AppSubnet resources are moved or deleted, changing AppSubnet to 10.40.0.64/26 supplies 59 usable addresses because Azure reserves 5 addresses. The prefix stays inside the parent/24 and occupies the free range from 10.40.0.64 through 10.40.0.127 without overlapping either adjacent subnet. For a subnet resize, subtract Azure's 5 reserved addresses from candidate capacity. Then reject any prefix that crosses the parent range or intersects a neighboring subnet. Question 3 of 31. A platform service must inject service-specific resources into an existing virtual network and establish the basic network configuration rules needed by its instances. The service's deployment model requires its instances to be isolated from other workloads. The virtual network contains a general-purpose workload subnet and a subnet used by a different injected service. The unused prefix 10.50.2.0/24 meets the new service's address requirement. Existing resources and subnets must remain unchanged. Which subnet configuration should the administrator use for the new service? Answer A. Deploy the platform service into the general purpose subnet and associate a separate NSG with that subnet. Answer B. Change the existing injected service subnet to the new platform service in its delegation list. Answer C. Create 10.50.2.0/24, associate an NSG with it, and leave its subnet delegation set to none. Answer D. Create 10.50.2.0/24 and select the platform service in the subnet's delegation list. Lock in your answer. That makes D correct. Create 10.50.2.0/24 and select the platform service in the subnet's delegation list. Create a new subnet from the unused prefix and select the platform service in that subnet's delegation list. Subnet delegation explicitly permits the service to create service-specific resources and establish supported basic network rules. An NSG only filters traffic, and changing the subnet used by the other service would violate the preservation requirement. When an injected Azure service must create service-specific subnet resources, identify the subnet scope permission mechanism, rather than substituting traffic filtering. Question 4 of 31. VM1 has a primary network interface named NIC1 in front-end subnet. Security rules and routes required by VM1 are already associated with BackendSubnet. Both subnets are in VNet 1, and BackendSubnet has available addresses. Every private IP configuration on NIC1 uses dynamic assignment. VM1 may remain running and no DNS change is required. Which action places VM1 under the subnet level controls of BackendSubnet? Answer A. On NIC1, open IP configurations and change the assigned subnet to BackendSubnet. Answer B. On NIC1, change its virtual network assignment to a new virtual network containing BackendSubnet. Answer C. On NIC1, change only the private IP allocation method from dynamic to static. Answer D. On VNet 1, change the DNS server settings to match BackendSubnet. Lock in your answer. Choose answer A. On NIC1, open IP configurations and change the assigned subnet to BackendSubnet. NIC can change subnets within its current virtual network when all of its private IP addresses use dynamic assignment. Selecting BackendSubnet in NIC1's IP configurations moves the NIC. This causes Azure to assign dynamic addresses from the destination range. It also makes the destination subnets, routes, and security controls applicable. To move a VM between subnets in one virtual network, verify that every NIC private address is dynamic. Then change the subnet on the NIC IP configuration, rather than changing DNS or allocation alone. Question 5 of 31. Hub VNet and Spoke VNet have connected peering objects in both directions. A network virtual appliance in Hub VNet forwards packets from another connected network to a VM in Spoke VNet. The appliance, user-defined routes, and security rules are already configured, but the packets stop at the peering boundary. Which peering setting should you change? Answer A. On Hub VNet's peering to Spoke VNet, enable Allow Gateway Transit. Answer B. On Hub VNet's peering to Spoke VNet, enable Allow Forwarded Traffic. Answer C. On Spoke VNet's peering to Hub VNet, enable Allow Forwarded Traffic. Answer D. On Spoke VNet's peering to Hub VNet, enable Use Remote Gateways. Lock in your answer. The network constraint points to C. On Spoke VNet's peering to Hub VNet, enable Allow Forwarded Traffic. The receiving side peering must permit packets forwarded into Spoke VNet by an appliance in Hub VNet. Therefore, Allow Forwarded Traffic is enabled on Spoke VNet's peering to Hub VNet. Gateway transit settings solve a different requirement. For NVA forwarded traffic, evaluate each directional peering from the receiving virtual network's perspective, rather than substituting gateway transit settings. Question 6 of 31. Hub VNet has a VPN gateway that provides connectivity to an on-premises network. Spoke VNet is peered with Hub VNet, has no gateway, and must use the Hub gateway. The virtual network address spaces do not overlap. Both directional peering objects must be configured for gateway transit. Which setting belongs on each peering object? Requirement 1. Hub VNet to Spoke VNet peering. Requirement 2. Spoke VNet to Hub VNet peering. Answer A. Enable the Spoke to use the peered virtual network's remote gateway. Answer B. Allow the Hub gateway to forward traffic to the peered virtual network. Lock in your answer. Resolve the network map this way. Requirement 1 matches answer B. Allow the Hub gateway to forward traffic to the peered virtual network. Requirement 2 matches answer A. Enable the Spoke to use the peered virtual network's remote gateway. Gateway transit requires complementary settings. The Hub side peering advertises that the Hub gateway may forward traffic to the Spoke, while the Spoke side peering authorizes Spoke VNet to use Hub VNet's remote gateway. This lets gateway-connected routes propagate to the Spoke without deploying a Spoke gateway. In gateway transit, configure the gateway owning side to share or forward through its gateway, and the gateway consuming side to use the remote gateway. Question 7 of 31. Spoke A and Spoke B have non-overlapping address spaces. Each Spoke has a connected bidirectional peering with Hub VNet, but the Spokes are not peered with each other. Hub VNet has no firewall or other network virtual appliance, and no user-defined routes provide inter-Spoke forwarding. A VM in Spoke A must communicate privately with a VM in Spoke B. Which change creates the required network path with the fewest new components? Answer A. Create a public DNS record that resolves both VM names. Answer B. Add NSG rules in both Spokes that allow the other Spoke's address space. Answer C. Enable forwarded traffic on both existing hub-to-Spoke peerings. Answer D. Create both directional peering objects directly between Spoke A and Spoke B. Lock in your answer. The supported network action is D. Create both directional peering objects directly between Spoke A and Spoke B. Virtual network peering is non-transitive, so the two hub-to-Spoke peerings do not create an implicit Spoke A to Spoke B path. Because their address spaces do not overlap, creating the two directional peerings directly between the Spokes provides the deliberate private path without adding an NVA and UDR design. When two Spokes connect only to a hub, assume no transitivity. Add direct Spoke connectivity or build an explicit routed hub path with both routing and a forwarding appliance. Question 8 of 31. VNet A uses 10.70.0.0/16 and cannot be renumbered. VNet B uses 10.70.128.0/17 and can be renumbered. No peering exists. The two virtual networks must communicate over a direct peering. Which action makes the virtual networks eligible for peering? Answer A. Replace VNet B's address space with 10.71.0.0/16 and then create the peering objects. Answer B. Create the peering objects with the current ranges and then replace VNet B's address space with 10.71.0.0/16. Answer C. Replace VNet B's address space with 10.70.128.0/18 and then create the peering objects. Answer D. Add 10.71.0.0/16 to VNet B. Retain 10.70.128.0/17 and then create the peering objects. Lock in your answer. Answer A is correct. Replace VNet B's address space with 10.71.0.0/16 and then create the peering objects. VNet B's 10.70.128.0/17 is contained in VNet A's 10.70.0.0/16. Peered virtual networks must have non-overlapping address spaces. Replacing VNet B's overlapping range with 10.71.0.0/16 removes the conflict. Adding a non-overlapping range while retaining the overlapping one does not. Check every prefix on both peering participants for overlap. Adding one valid prefix does not offset an overlapping prefix that remains assigned. Question 9 of 31. You are creating a new Azure-managed public IP for a regional application frontend. The selected region has 3 live availability zones. The frontend address must remain available if any one zone fails. Which public IP configuration meets the requirement? Answer A. Standard SKU with availability zone set to zone 1. Answer B. Basic SKU with no availability zone setting. Answer C. Standard SKU with availability zone set to zone redundant. Answer D. Global tier public IP with no availability zone setting. Lock in your answer. The supported answer is C. Standard SKU with availability zone set to zone redundant. A zone redundant standard public IP spans multiple zones and can survive one zone failure. Basic public IP addresses retired on September 30th, 2025. Microsoft also states that formerly non-zonal standard public IP addresses are now equivalently zone redundant in regions with availability zones. Among the listed options, Zone 1 is zonal, while Global Tier serves cross-region load balancing. Match the choice to the failure boundary. Use zone redundant placement for a regional zone outage, not a single zone or a cross-region tier. Question 10 of 31. An application receives inbound traffic through the front end of Azure Load Balancer LB1. A partner will allow list the application's public IPv4 address, so the address must remain stable. LB1 supports public IP association. You must not redesign the load balancing architecture. Which configuration should you use? Answer A. Create a static public IP. Assign it a DNS label and leave it unassociated. Answer B. Create a static public IP and associate it with an unrelated VM network interface. Answer C. Create a static public IP and associate it with the LB1 frontend. Answer D. Create a dynamic public IP and associate it with the LB1 frontend. Lock in your answer. That makes C correct. Create a static public IP and associate it with the LB1 front end. Standard public IPv4 addresses are static. Associating one with the LB1 front end puts the stable allow listed address on the resource that receives inbound traffic. Dynamic public IP allocation belongs to retired basic SKU legacy behavior. Basic public IP addresses retired on September 30th, 2025. For a stable inbound identity, use a standard static public IP and attach it to the actual front end. Question 11 of 31. A company deploys an internet-facing scale-out workload in the East US region of Subscription 1. A partner will accept only one contiguous CIDR range in its firewall allow list. New front-end instances must receive public addresses without requiring the partner to add a firewall rule for each instance. Which public IP configuration should you implement? Answer A. Create a public IP prefix in East US and Sub 1, and create standard static public IP resources from that prefix for the front ends. Answer B. Create a public IP prefix in East US and Sub 1, and create dynamic public IP resources from that prefix for the front ends. Answer C. Create a public IP prefix in East US in another subscription, and create the front-end public IP resources in Sub 1 from that prefix. Answer D. Create separate standard static public IP resources in East US without a public IP prefix, and assign one to each front end. Lock in your answer. Choose answer A. Create a public IP prefix in East US and Sub 1, and create standard static public IP resources from that prefix for the front ends. A public IP prefix reserves a contiguous Azure public address range. Standard static public IP resources created from the prefix in the same region and subscription can be assigned to the front ends. The partner can allow list the prefix once, and later prefix-derived addresses remain within that managed range. When a third party must allow list a stable contiguous range before a workload scales, distinguish prefix-derived public IP resources from merely separate public IP resources. Question 12 of 31. AppSubnet is associated with route table RTApp. RTApp contains a route for 10.42.0.0/16 that sends traffic to virtual appliance 10.0.1.4. Traffic from AppSubnet to the protected range 10.42.16.0/24 must instead use virtual appliance 10.0.2.4. Traffic to all other addresses in 10.42.0.0/16 must continue to use 10.0.1.4. Which route configuration meets the requirements? Answer A. Add 10.42.16.0/25 with next hop 10.0.2.4 to RTApp. Answer B. Add 10.42.16.0/24 with next hop 10.0.2.4 to RTApp. Answer C. Add 10.42.16.0/24 with next hop 10.0.2.4 to a route table associated only with a neighboring subnet. Answer D. Change 10.42.0.0/16 to use next hop 10.0.2.4 in RTApp. Lock in your answer. The network constraint points to B. Add 10.42.16.0/24 with next hop 10.0.2.4 to RTApp. Azure evaluates overlapping destination routes by longest prefix match. The 10.42.16.0/24 route is more specific than 10.42.0.0/16, so it sends the protected range to 10.0.2.4. The existing /16 route remains applicable to the rest of the broader range. The route must be in the table associated with the source subnet. For overlapping Azure routes, first identify the narrowest destination prefix that must change paths. Then place that route in the source subnet's associated route table. Question 13 of 31. AppSubnet is associated with RTApp. A firewall virtual appliance has private IP address 10.1.0.4. Traffic from AppSubnet to destinations that are not matched by a more specific route must be sent to the appliance for inspection. Azure IP forwarding and the appliance operating system's forwarding configuration are enabled, and the return path is configured. Which route should you configure? Answer A. In RTApp, add 0.0.0.0/0 with next hop type internet. Answer B. In RTApp, add 10.1.0.4/32 with next hop type virtual appliance and next hop address 10.1.0.4. Answer C. In RTApp, add 0.0.0.0/0 with next hop type virtual appliance and next hop address 10.1.0.4. Answer D. In the appliance subnets route table, add 0.0.0.0/0 with next hop type virtual appliance and next hop address 10.1.0.4. Lock in your answer. Use answer C. In RTApp, add 0.0.0.0/0 with next hop type virtual appliance and next hop address 10.1.0.4. RTApp is associated with AppSubnet, so its routes govern traffic originating from that subnet. For destinations that have no more specific route, 0.0.0.0/0 is the matching prefix. Setting its next hop type to virtual appliance and its next hop address to 10.1.0.4 sends that default route traffic to the prepared appliance. A route on the appliance subnet would not govern AppSubnet's originating traffic. A default UDR applies only where no more specific prefix wins. Then its next hop type and source subnet route table association determine whether that traffic traverses an appliance. Question 14 of 31. A virtual network uses a VPN gateway that propagates on-premises routes. Isolated subnet is associated only with RT isolated. Its effective routes currently include BGP, propagated on-premises prefixes, but the subnet must use the explicit routes already defined in RT isolated, and must not receive the gateway propagated routes. Other subnets use different route tables and must continue to receive the propagated routes. What should you change? Answer A. Remove the explicit routes from RT isolated while leaving gateway route propagation enabled. Answer B. Disable virtual network gateway route propagation on RT isolated. Answer C. Delete the virtual network gateway from the virtual network. Answer D. Disable virtual network gateway route propagation on the route tables used by the other subnets. Lock in your answer. The supported network action is B. Disable virtual network gateway route propagation on RT isolated. Gateway route propagation is controlled on a route table. Disabling it on RT isolated prevents the gateway's on-premises routes from propagating to network interfaces in isolated subnet, while leaving the table's explicit routes intact. Because the other subnets use different route tables, their propagation settings can remain enabled. When only selected subnets must ignore gateway advertised paths. Look for the propagation setting on each subnet's associated route table rather than a gateway-wide change. Question 15 of 31. VM app has a network interface in AppSubnet. The VM must use a custom route that already exists in RT inspection. The effective routes for VM app do not include that route. RT inspection is currently associated with neighbor subnet, and AppSubnet has no route table association. Which action makes the existing custom route applicable to VM app? Answer A. Create another copy of the route in RT inspection and leave its subnet associations unchanged. Answer B. Associate RT inspection with the destination workload subnet. Answer C. Create a new route table containing the same route and leave the new table unassociated. Answer D. Associate RT inspection with AppSubnet. Lock in your answer. Answer D is correct. Associate RT inspection with AppSubnet. Azure applies a route table's routes to traffic from a subnet through the subnet to route table association. Associating RT inspection with AppSubnet allows its custom route to combine with AppSubnet's default routes and enter VM app's effective route set. If a custom route exists but is absent from a source NIC's effective routes, verify the route table association of the NIC's subnet before recreating the route. Question 16 of 31. A running VM sends traffic through an unexpected egress path. Several Azure default, custom, and BGP propagated routes can match the destination. Before changing any route, an administrator must inspect the complete applied route inventory for the VM's network interface, including prefixes and route sources, to identify the responsible route object. Which diagnostic view should the administrator use? Answer A. IP flow verify for one traffic tuple. Answer B. Connection monitor reachability results. Answer C. Effective routes on the VM's network interface. Answer D. Network watcher next hop for one destination IP. Lock in your answer. The supported answer is C. Effective routes on the VM's network interface. The NIC's effective routes view presents the applied aggregate of Azure default routes, custom routes, and BGP propagated routes for that interface. It provides the inventory, prefixes, and route sources needed to identify the route that should later be repaired without making a configuration change first. Choose an effective state inventory when the task is to identify every applied route and its source. Choose a targeted path test only when one destination outcome is sufficient. Question 17 of 31. A running VM has one NSG associated with its network interface and another NSG associated with its subnet. Connectivity for a known traffic class is unexpected. Before editing either NSG, an administrator needs the full aggregated rule inventory for the selected interface, including the rules and priorities from both association levels. A single packet tuple result is not sufficient. Which diagnostic view should the administrator use? Answer A. A packet capture on the VM's network interface. Answer B. IP flow verify for the known traffic tuple. Answer C. Network watcher next hop for the destination address. Answer D. Effective security rules on the VM's network interface. Lock in your answer. That makes D correct. Effective security rules on the VM's network interface. Effective security rules aggregate the rules from network security groups associated with the NIC and its subnet. The per-interface view exposes both rule sets for comparison before either NSG is changed, and the full list can be exported when needed. When multiple NSG attachment levels may interact, inspect the selected NIC's effective security rules before relying on a one-tuple allow or deny test. Question 18 of 31. A VM cannot establish a TCP connection to 10.70.8.20 on port 443. The path traverses several routing and security hops. The destination IP address and port are known, and no configuration changes are authorized until the failing path segment or endpoint condition is identified. Which diagnostic should you run first to obtain reachability status and hop-level issue details? Answer A. Start a packet capture on the VM and infer the failing hop only from the captured packets. Answer B. Run Network Watcher connection troubleshoot from the VM to 10.70.8.20 by using TCP port 443. Answer C. Run a DNS lookup for 10.70.8.20 and use the lookup result as the path diagnosis. Answer D. Review only the source NIC's effective routes and use that inventory as the end-to-end hop diagnosis. Lock in your answer. Choose answer B. Run Network Watcher connection troubleshoot from the VM to 10.70.8.20 by using TCP port 443. Connection Troubleshoot can test a TCP connection from a supported Azure source to an IP address destination. Its result includes reachable or unreachable status and a hop-by-hop path. The issue fields on each hop identify where an issue was encountered and provide its origin, severity, type, and context without requiring a configuration edit. When the endpoint tuple is known, but several hops could fail, prefer a connection diagnostic that reports both overall reachability and per-hop issues before changing configuration. Question 19 of 31. A client must connect to the intended service at 10.80.4.20 on TCP port 443 by using the name app.internal. Test net connection to 10.80.4.20 on port 443 returns TCP test succeeded as true. A test to app.internal on the same port returns 10.80.4.99 in name resolution results instead of 10.80.4.20. No endpoint authorization error is reported. Which area should you investigate first? Answer A. The effective route to the already reachable address 10.80.4.20. Answer B. The service authorization policy for the connection before name resolution. Answer C. The resolver path and DNS mapping for app.internal. Answer D. The NSG rules for the already successful TCP flow to 10.80.4.20 on port 443. Lock in your answer. The network constraint points to C, the resolver path, and DNS mapping for app.internal. The two tests hold the intended service port constant while varying the computer name input between the known IP and the FQDN. The known IP TCP test succeeds while the FQDN resolves to an unexpected address. That evidence isolates the first investigation to name resolution rather than the already successful route and transport path to 10.80.4.20 on port 443. To isolate DNS from transport, compare an FQDN and its known intended IP with the same destination port. Investigate the layer where the outputs first diverge. Question 20 of 31. An NSG associated with Manage Subnet contains an inbound rule named Deny SSH with priority 300. The rule denies TCP traffic from any source to destination port 22. Administrators from 198.51.100.0/24 must be able to initiate SSH connections to workloads in the subnet. No other source should be newly permitted. Which custom NSG rule should you add? Answer A. Allow inbound TCP from 198.51.100.0/24 to destination port 22 with priority 250. Answer B. Allow inbound TCP from any source to destination port 22 with priority 250. Answer C. Allow outbound TCP from 198.51.100.0/24 to destination port 22 with priority 250. Answer D. Allow inbound TCP from 198.51.100.0/24 to destination port 22 with priority 350. Lock in your answer. Use answer A. Allow inbound TCP from 198.51.100.0/24 to destination port 22 with priority 250. The management connection is initiated externally, so the rule must be inbound. Matching the trusted CIDR, TCP, and destination port 22 limits the new access to the required packet tuple. Azure evaluates lower priority numbers first, so priority 250 allows the trusted flow before the broader deny at priority 300 is evaluated. For a narrow NSG exception, match the initiating direction and exact 5-tuple scope, then choose a numerically lower priority than any broader conflicting rule. Question 21 of 31. A virtual network contains an application subnet and a data subnet. 3 application virtual machines initiate TCP connections to 2 database virtual machines on destination port 1433. The private addresses of the virtual machines can change during routine replacement. An NSG on the data subnet is the enforcement point, and no existing custom rule permits this traffic. Only members of the application tier should receive the source exception. All 5 network interfaces are in the same virtual network. Which configuration permits the required traffic with the least ongoing address maintenance? Answer A. Assign the application network interfaces to app tier and the database network interfaces to data tier. Add an inbound allow rule from data tier to app tier on TCP destination port 1433. Answer B. Assign all application and database network interfaces to app tier, and also assign the database network interfaces to data tier. Add an inbound allow rule from app tier to data tier on TCP destination port 1433. Answer C. Assign the application network interfaces to app tier and the database network interfaces to data tier. Add an inbound allow rule from app tier to data tier on TCP destination port 1433. Answer D. Add inbound TCP 1433 allow rules that list the current private address of each application NIC as a source and the database subnet as the destination. Lock in your answer. The supported network action is C. Assign the application network interfaces to app tier and the database network interfaces to data tier. Add an inbound allow rule from app tier to data tier on TCP destination port 1433. Application security groups let an NSG rule follow tier membership instead of changing private IP addresses. Assigning application network interfaces to app tier and database network interfaces to data tier allows the inbound TCP 1433 rule to name only the required initiator and destination tiers. Non-member network interfaces are not covered by that ASG-based rule. Use distinct application security groups for stable workload identity, preserve initiator to target direction, and keep non-application network interfaces outside the source group. Question 22 of 31. Subnet app. Subnet is protected by NSG app. An existing outbound rule at priority 200 allows approved virtual network traffic. New TCP connections from AppSubnet to destinations represented by the storage service tag must be blocked only when the destination port is 443. Other ports to that service and the approved virtual network traffic must continue to be evaluated by the existing rules. Which custom rule should you add to NSG app? Answer A, priority 150, outbound, source any, destination storage, protocol any, destination port any, deny. Answer B, priority 150, outbound, source any, destination storage, protocol TCP, destination port 443, deny. Answer C, priority 150, inbound, source any, destination storage, protocol TCP, destination port 443, deny. Answer D, priority 150, outbound, source any, destination any, protocol TCP, destination port 443, deny. Lock in your answer. Answer B is correct. Priority 150, outbound, source any, destination storage, protocol TCP, destination port 443, deny. The required rule must evaluate outbound connections, identify the prohibited destination by its service tag, and restrict only TCP destination port 443. Priority 150 gives the custom deny precedence over the visible rule at priority 200, while leaving non-matching traffic for later rules to evaluate. For a narrow egress restriction, align direction, destination abstraction, protocol, port, and priority, so only the prohibited tuple matches first. Question 23 of 31. Subnet workload. Subnet contains 6 virtual machines. Every VM requires the same inbound baseline policy. Only VM 6 requires an additional host-specific inbound restriction. The design permits an NSG at the subnet and another NSG on the network interface of VM 6. And both associated network security groups can contribute to the effective packet decision. Where should each policy requirement be placed to keep its enforcement scope as narrow as appropriate? Requirement 1. Common inbound baseline for all 6 virtual machines. Requirement 2. Additional inbound restriction for VM6 only. Answer A. NSG associated with the network interface of VM6. Answer B. NSG associated with workload subnet. Lock in your answer. The correct matches are: Requirement 1 matches answer B, NSG associated with workload subnet. Requirement 2 matches answer A, NSG associated with the network interface of VM6. A subnet-associated NSG affects all resources in that subnet, so it is the appropriate shared scope for the common baseline. A NIC-associated NSG adds a scope specific to that interface, so the additional VM6 restriction belongs there. Packets governed by both associations must survive both applicable NSG evaluations. Associate shared NSG policy at subnet scope and exceptional host policy at NIC scope then account for every scope traversed by the packet. Question 24 of 31. A client initiates an inbound TCP 443 connection to VM1. Routing to VM1 is valid. NSG subnet is associated with VM1 subnet and contains a matching inbound allow partner 443 rule. NSG NIC is associated with VM1's network interface and contains a matching inbound deny partner 443 rule. No higher priority rule matches the packet in either NSG. What is the effective result for the connection? Answer A. The connection is denied by NSG subnet because a subnet NSG cannot allow traffic to an NIC that also has an NSG. Answer B. The connection is denied by deny partner 443 in NSG NIC after NSG subnet allows the packet to continue. Answer C. The connection is allowed because NSG subnet evaluates first and its allow decision is final. Answer D. The connection is allowed because an allow at either associated NSG is sufficient for inbound traffic. Lock in your answer. That makes B correct. The connection is denied by deny partner 443 in NSG NIC after NSG subnet allows the packet to continue. For inbound traffic, Azure evaluates the subnet-associated NSG before the NIC-associated NSG. The subnet allow lets processing continue, but it does not bypass the NIC NSG. Because the matching NIC rule denies the packet, the combined effective result is denial. Evaluate a packet across every associated NSG in direction-specific order. An allow at an earlier scope only permits evaluation to continue. Question 25 of 31. An administrator establishes an SSH session to a virtual machine through an NSG rule that allows TCP/22. While the session is active, the administrator removes that allow rule. A matching deny now governs new TCP/22 connections. The route and both endpoints remain unchanged. The administrator keeps using the established session and separately attempts a new SSH session from the same client. What result should the administrator expect for each observation? Requirement 1. The SSH session established before the rule removal. Requirement 2. The new SSH connection attempted after the rule removal. Answer A. Is blocked by the effective deny. Answer B. Remains connected and functional. Lock in your answer. The correct matches are Requirement 1 matches answer B, remains connected and functional. Requirement 2 matches answer A, is blocked by the effective deny. Network security groups maintain flow records for established connections. Updating or removing a rule applies to new connections and does not retroactively interrupt the established SSH flow. The later SSH attempt is a new connection, so it is evaluated against the changed rules and is denied. After an NSG edit, test established and newly initiated sessions separately because retained flow state and current rule evaluation answer different questions. Question 26 of 31. An NSG has two inbound TCP rules. Deny web has priority 200 and denies source any to destination port 443. Allow partner has priority 300 and allows source 203.0.113.10 to destination port 443. A new connection from 203.0.113.10 is denied. You must make the intended partner connection match allow partner before deny web without changing the rule's direction, source, protocol, or destination port. Which change meets the requirement? Answer A. Change the priority of allow partner from 300 to 150. Answer B. Change the priority of allow partner from 300 to 350. Answer C. Create an outbound copy of allow partner at priority 150. Answer D. Change the priority of allow partner from 300 to 250. Lock in your answer. The network constraint points to A. Change the priority of allow partner from 300 to 150. NSG rules are processed from lower priority numbers to higher numbers, and evaluation stops at the first match. The broad deny at 200 currently matches before the narrow allow at 300. Moving allow partner to 150 makes that intended inbound rule the first match for the partner tuple. NSG specificity does not outrank priority. Place the intended same direction exception at a lower number than the broader matching rule. Question 27 of 31. A workload sends a new outbound TCP connection on destination port 443. DNS has resolved the destination, and the resolved address is represented by the storage service tag. The workload's NSG has these rules, each with source any, priority 110, outbound deny, destination any, protocol UDP, port any. Priority 120, inbound deny, destination storage, protocol TCP, port 443. Priority 130, outbound allow, destination storage, protocol TCP, port 443. Priority 140, outbound deny, destination any, protocol any, port any. Which rule determines the packet's effective access decision? Answer A, the priority 120 inbound storage TCP 443 deny. Answer B, the priority 140 outbound any deny. Answer C, the priority 110 outbound UDP deny. Answer D, the priority 130 outbound storage TCP 443 allow. Lock in your answer. Use answer D. The priority 130 outbound storage TCP 443 allow. The packet is outbound TCP 443 to an address represented by storage, and every listed rule has source any. Priority 110 fails the protocol match, and priority 120 fails the direction match. Priority 130 is therefore the first rule whose direction, source, destination, protocol, and port all match, so it allows the connection, and evaluation stops before priority 140. An NSG rule must match source, direction, protocol, destination, and port. Evaluation stops at the first complete match by priority. Question 28 of 31. You will deploy a dedicated Azure Bastion host that is not the developer offering. The host will be created in VNet Hub in resource group RG Network. VNet Hub has unused address ranges, and the prepared Bastion subnet must contain no other resources. Which subnet should you prepare for the deployment? Answer A, Azure BastionSubnet using 10.40.1.0/26 in VNet Hub and RG Network. Answer B, Azure BastionSubnet using 10.80.1.0/26 in VNet Tools and RG Network. Answer C, Azure BastionSubnet using 10.40.1.0/27 in VNet Hub and RG Network. Answer D, Bastion Subnet using 10.40.1.0/26 in VNet Hub and RG Network. Lock in your answer. The supported network action is A, Azure Bastion Subnet using 10.40.1.0/26 in VNet Hub and RG Network. A dedicated non-developer Bastion deployment requires the reserved subnet name Azure Bastion Subnet and a prefix of /26 or larger. The subnet must be in the same virtual network and resource group as the Bastion host and cannot contain other resources. Option A satisfies all of these prerequisites. Validate a dedicated Bastion subnet as a joint prerequisite. Exact reserved name, sufficient prefix, host local placement, and no other resources. Question 29 of 31. 4 virtual machines in VNet Prod have only private IP addresses. Administrators need supported RDP access to 2 Windows virtual machines and SSH access to 2 Linux virtual machines. Security policy prohibits assigning public IP addresses to the target virtual machines or exposing direct inbound administrative endpoints from the internet. Which implementation provides the required administrative access? Answer A, deploy Azure Bastion in VNet Prod and initiate RDP or SSH sessions to the target virtual machines by their private IP connectivity. Answer B, assign a public IP to each target VM and allow inbound RDP or SSH in the VM's NSG. Answer C, add inbound NSG allow rules for RDP and SSH to the private-only target virtual machines without deploying an administrative access service. Answer D, place the target virtual machines behind a load balancer and create inbound load balancing rules for RDP and SSH. Lock in your answer. Answer A is correct. Deploy Azure Bastion in VNet prod and initiate RDP or SSH sessions to the target virtual machines by their private IP connectivity. Azure Bastion is the managed service designed to provide RDP and SSH connectivity to virtual machines over TLS, while reaching target virtual machines through private IP addresses. The target virtual machines do not require public IP addresses, an agent, or special client software. So the design preserves the direct exposure prohibition. When administrative protocols are required, but VM public endpoints are forbidden, choose a managed access path that reaches the workload over private addressing. Question 30 of 31. A production virtual network requires a dedicated Azure Bastion deployment. The security design requires the Bastion deployment itself to be private only and non-internet routable, with no public IP connection to the Bastion host. The target virtual machines also retain only private IP addresses. An unused /26 range is available in the virtual network. Which Bastion configuration satisfies the complete design? Answer A. Premium SKU, a gateway subnet using the /26 range, and private-only deployment with no public IP. Answer B. Premium SKU, an Azure Bastion subnet using the /26 range and private-only deployment with no public IP. Answer C. Standard SKU, an Azure Bastion subnet using the /26 range and private-only deployment with no public IP. Answer D. Basic SKU, an Azure Bastion subnet using the /26 range and a standard static public IP. Lock in your answer. The supported answer is B. Premium SKU, an Azure Bastion subnet using the /26 range and private-only deployment with no public IP. Private-only Bastion deployment is a premium capability and does not require a public IP. Premium is a dedicated deployment and therefore requires Azure Bastion subnet-sized /26 or larger. This combination preserves the required non-internet routable Bastion architecture and the private-only target virtual machines. Treat Bastion SKU, subnet, and front-end address mode as a coupled selection. A capability from one SKU cannot be assumed for another. Question 31 of 31. VNet Hub contains an existing basic Azure Bastion host. VM1 is in VNet Spoke, has no public IP address, and must be administered through the Hub Bastion host. The virtual networks have non-overlapping address spaces. A hub-to-spoke peering has been created, but the reciprocal peering has not been created, and the existing peering does not report connected. What should you do before testing a Bastion session to VM1? Answer A. Create the reciprocal spoke-to-hub peering. Verify that both peering resources report connected, and then use the existing basic Bastion host. Answer B. Use the existing one-way peering immediately, because a single peering resource is sufficient for Bastion connectivity. Answer C. Replace the basic Bastion host with the developer offering, and use the existing one-way peering. Answer D. Link a private DNS zone to both virtual networks, and use the existing one-way peering without creating the reciprocal peering. Lock in your answer. That makes A correct. Create the reciprocal spoke-to-hub peering. Verify that both peering resources report connected, and then use the existing basic Bastion host. Basic supports connections to virtual machines in peered virtual networks, so another Bastion host is not required in VNet Spoke. Resource Manager Virtual Network Peering requires a peering resource in each direction, and the relationship is not successfully established until both peerings report connected. After that, the existing hub Bastion can reach the private-only Spoke VM. For Bastion access across peering, verify both the SKU's peered network capability and the two-direction connected peering state before troubleshooting the session. Confidence check. For each networking decision, trace the source, destination, route, security evaluation, and administrative access boundary. If you can explain those 5 checks, you are building administrator-level judgment rather than memorizing isolated settings. Thanks for practicing Core Azure Networking with WebLizard Labs CertLab. Keep tracing packet paths, effective routes, security rules, peering state, address boundaries, and private administrative access.